to Los Angeles Data Platform. It's great that I finally was able to say that instead of SQL Malibu. We have a presentation by Rob Girard, and the presentation is Next Generation Intelligent Infrastructure, Tintri SQL Integrated. There might be also joined by Shawn Meyers. Sponsors for today's meeting is Redgate. And with that, I'm going to transfer that to Rob. Thanks for deciding to spend your time on Wednesday and talk about next generation intelligence infrastructure.
Will do.
And of course,
a lot, Steve.
Welcome to all of our attendees.
Thank you, Steve, and welcome everyone. So I'm going to keep today little somewhat informal, interactive. Feel free to ask questions about what you're seeing. Encourage questions, and so what I want to share with you is so I work with Tintri.
Rob, you need
I'll
to
share my screen. Yep.
Yes, perfect.
All right. Not too much to see on the screen just yet. I decided to go interactive demo route instead of PowerPoint. I could do PowerPoint, but I'm sure you can get plenty of that elsewhere. I work with Tintri. So Tintri creates intelligent infrastructure, storage specifically, and we built a storage appliance from the ground up for virtualization to handle all of the tough challenges in a virtual workload. And what we've done recently and just GA'd earlier this year is what we call SQL Integrated Storage. So we took the same smarts that we have for virtualization and applied it to SQL. So essentially what this is, it is a hardware appliance, or many of them, that is storage for SQL that does not require storage expertise. It does all kinds of auto tuning. It abstracts out all of the craziness that storage usually has around LUNs and volumes and stuff, and allows us to just create a nice big SMB share that we can put our SQL databases in. And usually when I say SMB, I get a few people that cringe. So this SMB3 is a protocol stack that we built from the ground up to support our Hyper-V workloads since 2014. And so has had a lot of time in the field, a lot of enterprise adoption, and now we've moved it towards SQL. And so what's really cool is we get this ease of use of just having a file share, but then the smarts and the backend horsepower that separates out all of your files into distinct databases, into their own lanes, so that database and VM activity from some databases don't impact others. And it does this dynamically, and that's what I want to show you today is kind of how it works and what the user experience is like for it. So for, yep.
Quick question. I'm sure you're going to cover it at some point, but just to make sure you can basically dump any file. So you can, so normally in SQL Server, you should have its own file, its own drive for TempDB, its own log, its own data. What you're saying is you can dump everything into one.
Yeah, so the normal best practices, our best practices at Tintri for SQL Server are to create a VM that has 7 vDisks. And those vDisks would be your OS page, you've got a data, you've got a log, you got a temp data, temp log, and then a backup. And then I would typically recommend for additional databases to give them a pair of vDisks each and then spread them across different SCSI controllers. And so what we're doing is to, what we did on the VMware side to simplify things is allow customers to have just one big data store that you put all your VMs in. And by doing that, that breaks all the rules of VMware that says you can't put more than a certain amount at the same time, and some other things, some other constraints. And so we remove those strict constraints through our custom file system that was built from the ground up to do this. So our founder was Kieran Hardy, who was VMware employee number 25 and EVP over at VMware that led engineering from almost inception right up through till 2007. 2008, he founded Tintri. And so we've been around for what, 12 years, I guess now. We became GA with our first product in 2011. And I've been with Tintri since, I guess, January 2014, and I was a customer for a couple of years before that. So, so what we've got here is, this is Tintri Global Center dashboard. This is kind of our older looking dashboard, so the colors aren't all that updated. A lot of our content is, but not our main dashboard. And I can look at some storage characteristics. So I can look at throughput, for example. And so this is the throughput that is across the various VM stores in my environment. A VM store is the name of our hardware appliance. So when I say that, and I can see latency on here, which, you know, for storage you typically do. Now, where it differs from most storage, or more or less all, except for some that can do it in post-process, is this real-time display that shows latency breakdown, not just storage, but host and network latencies as yellow and green. So this is what will tell you if you have any kind of bottleneck between your servers and the storage itself. So this isn't the front-end client network. So if you were to take a SQL Server and set it up with a single NIC on, say, a 10 gig, and you've got client traffic and back-end database traffic, if that line is being constrained and that database is getting latency from it, it might look like storage latency, but it might actually be the path to storage. So by breaking this out, we help. But we can only break this out to do this when we know the I/O for every single file and every database. And so we have flash counters on all of our blocks. And using this custom file system we've mapped all of the databases and stuff on there so that we can kind of know who's doing what and have individual track record and keep them separated. So in practice, what does that mean? Here's a 1 week view, and I can look, and right here I see there's a spike. So if I click on that latency spike, what I can see is that it's not every system, every database, or every VM. This is actually just this VROPS VM got it really bad at 129 milliseconds. This one, which is my TGC that I'm on, had it at 49 milliseconds, and the others are lower to nearly non-existent. Same thing for throughput. So you can see there's some activity here that started up this morning, and I can see who those contributors are. So I've got one here that's clone test that was doing 408 megabytes per second. And I've got this happens to be a database. And so this is sort of that, the ease of who done it. So if you were to look at this and ask yourself, is my infrastructure healthy? And you're looking at this latency, which is an average across the board for everybody, and it's looking low, then you could really quickly just say yes, because when there is a big problem, it shows, and it usually shows by one type or another. So in this case, I'm actually seeing spikes on yellow, which is network latency. And I can see this one hit at 10 p.m., and I can see exactly who had that latency. Again, the latency may not be the same for everybody. So in this case, this AdventureWorks is what got squeezed out. And it was primarily on the network side. So if I wanted to look at this AdventureWorks database here, so I just clicked to it, and this is a list of all my databases. And a filter was just applied to filter this list to what it was at the time where I clicked on that graph. So I clicked as of September 14th at 10 p.m. And at that time, this is everything that was going on in this environment. And here is a particular database. And we can see that its latency was really bad at 218 milliseconds, but the storage latency was half a millisecond. And anybody monitoring this system would probably say this was a storage problem because they don't have a way to know how long it took for the IOs that were issued to actually reach the storage and be returned. And no other storage can do this unless they know the exact data that you're measuring. Because if I just took the average for the entire array, this would probably say that it was 10 milliseconds, which is what we saw on the other graph, because it would average everybody. But we actually know that this one had it bad. So now all of a sudden, everybody's on the same page from when performance isn't good. And now we know why it wasn't, and it was a network problem. So if we drill in a little further to this particular database, I'm just gonna hide this filter at the top here. Sorry, it took a sec to find it. And so here's a quick one-day summary. And I can drill in even closer on this database here and go to metrics. And on metrics, I can look at all of them. So in this case, I'm just going to say select all, just so I have a bunch. And I'll just take a look at the last week, I guess. So we hold 1 week on the appliance, on the VM store itself, 1 month in this Tintri Global Center, which is a virtual appliance running as a VM. And then we hold 3 years in Tintri Analytics, and we do trending and stuff with it. So here I can see that this is probably 10 p.m. No, this one's 7 p.m. This one is 7 p.m. And this one is 7 p.m. So really quickly, I can see that, hey, you know what? I'm getting network latency, or sorry, these are IOPS. I can go down to my latency, and I can see that sometimes I get latency at 10 p.m. and also at 10 p.m., which doesn't correspond to when most of the activity is. So the activity is always ongoing there, but we don't always get latency. So this kind of helps us drill down and figure out what else is going on. So at 10 p.m., I could easily go through and look at all the systems and see who's driving throughput. And odds are that throughput is squeezing out the available bandwidth, either on a host, on the SQL Server itself. It could be competition with other databases or a backup job. It could be a blade chassis, right? So these are the really tough things in infrastructure that have all the finger pointing, because to you as DBAs, you know, you're trying to run your stuff. You're saying, hey, it's slow. You talk to storage, says, no, it's not me. They show you on their array some proof that no, it's all flash and it's half a millisecond. Well, they're probably showing you an average, and it may not be the full truth, and it may not be end to end. So then we go and we okay, well, maybe it is the network, and the network guy pulls up all his displays and shows you that the network was clean and you didn't have any issues. So then, you know, they're pointing at you, oh, it's your queries and all this stuff. So what we have here is a really quick way to show that the infrastructure is clean. So it's not just the metrics here. Our devices are actually tuning themselves in real time to adjust to demand of workload through it, so that anything that was using resources can continue to and not get impacted by something that is would be considered a noisy neighbor. Now, let's say you've got a new workload, you just start pounding with a really ugly query, and you can't really control that it's going to hurt other people. Now, if we had something like that, and we knew that at a certain time that this would happen, we could easily go in and we could set some QoS. So we could set a quality of service on a particular database to say, hey, you can't go over a certain number of maximum normalized IOPS. So this takes IO and throughput into consideration. And if it does want to go over, it will see latency for everything above and beyond, but nothing else will be impacted by it. And so this is all great. And you might be wondering, you know, what's involved in the setup to see this list of databases. Because when I have this list, what I can easily do is I'm just going to go take my metrics and I'm going to clear that time. So I'm looking at right now. And then I'm going to sort by latency high to low. And just really quickly, does anybody in this environment have any issues? And I can see that AdventureWorks, DW, the data warehouse one, does have some network latency. I can see that prod AW also has some network latency. And I can add a whole bunch of fields here that might help narrow things down. So I'm going to select columns. And what I want to see here are the who the hosts are on these. And in this case, I've got one on PASS Dev. Another one is PASS Prod. Another one's PASS Prod. So I've now narrowed it down to, hey, it's only databases that belong to certain servers. And those certain servers might be, you know, in the same virtual host. They might be on the same ESX server. And so there could be some bottleneck on the network there. In this case, it's because, yes?
Quick question. What each color signifies?
Each color?
Yes, so there's yellow and there's like a grayish something.
Sorry about that. Let me just mouse over this. So when I mouse over, that yellow is network.
Got it.
And then blue is storage. And then the storage we actually subdivide. And Flash is the native latency of the media itself, of our file system. Contention is sort of a auto quality of service throttle that we apply to protect all the other workloads. So if one ramps up out of nowhere, it'll get some contention, it'll see high latency, but others won't. And then disk only applies to our hybrids. So if everything was not in Flash and there was a penalty for hitting something not in Flash, that would show up specifically as disk latency. And what we can see here that is different than other storage is that our Flash latencies aren't necessarily the same for every workload. So this one, which is a 4 terabyte SMB VM, has a latency at 2.2 milliseconds. This one here is the Flash on it is 1 millisecond. And we can go through and look at others. Now, the significance to that is that because we can have different latencies for each of them, that's because our file system can control that so that it's not a free-for-all. So all other storage, all traditional storage that use LUNs and volumes, it's just a big, massive queue, everything coming in. Sometimes it's split out by LUNs. And so to get this, you need to create a LUN per database. Or a pair of LUNs. One might be for your log files, one might be for data files. So what this has done is it's auto-discovered all the databases and created automatically. So just to show you that, I'm just going to go in here and I'm going to create a new database. And I am going to create one called SQL Malibu, even though it should be LA Data Platform. But we've got SQL Malibu, and then the rest, I'm just going to leave it. So I've already defaulted it to store in this SMB path, which is a path to the data IPs, the data share on this Tintri VM store, which is an EC6090. That's the biggest, most powerful in our all-flash lineup. And we're going to put it in this folder. So for the DBA, it just means, hey, here's a new database. Okay. And it gets deployed. It shows up, and if we were to browse that share, which is not that share, that one's an old one that doesn't exist anymore. So let me just HQTM. Oh, sorry about that. So I've got 3 shares that I'm allowed to see as an admin. Typically, we would not expose this Hyper-V share. It's sort of a master root share, but this is for the Hyper-V VMs and is the root of where our SMB creation came from. But it's not actually the hypervisor itself. That it supports the hypervisor for VMs in it. And it also supports all the NFS for all the VMs. Now, this is 2 folders, shares that I created, one for production, one for dev. And inside, I've got a subfolder here for this server. And I've got inside of here, all my MDFs and LDFs. And I believe, yeah, I just created this SQL Malibu here. And if I were to go back to my global center and look for any part of it, Mali, for example, I can see that I have an object already. So I didn't go and do anything. What happened is that we are polling, so we've created a session event timer on the SQL Server. And so when we added a SQL Server to our Tintri Global Center, it automatically created this. And if we remove that SQL Server from being managed, it will stop this. And all this is doing is collecting a few events, database creates, changes, drops, deletions, that kind of thing, so that we can check this. And this is just a rolling 5 meg memory. And so we can check this really often without taxing the server with a full inventory. And so when we check this, we see that a new one was created and we know the path to it. And so then what we do is we look at our internally and say, oh, well, these files are in our straight queue. We're going to create a new ID for it with the name of this database. And we're going to, and now that we've done that, it's just like we manually created a LUN for it. And by that auto creation, it's now just going to have all the auto QoS rules that take place in the environment. So this is like ready to go to start using right away for anybody who wanted their new database. And as you're using it, we'll see all the metrics automatically being collected for it. And then we've got the added bonus of being able to manage it. And so the management for it is to, we can set protection policy. So we can do it, let me just hit edit here. And I want to snap this one. So I don't want to take the defaults of the array that it's on, but I could have some defaults as a catch-all. And in this case, I want to say hourly, and I want to set this one at 5 minutes, 20 minutes, 35 minutes, and 50 minutes past the hour. So every 15 minutes, I want this to have a little snapshot. It's going to do a crash consistent snapshot. And that quick snapshot that we do is completely consistent. And you will never see any LDF, MDF, any LSN mismatches because all of the byte stream, all of the data coming in and out of here, there's no extra queues. There's just network buffers on the SMB side. It comes into our stack, and we process it in the order that we received it. And when we take snapshots, we make sure that everything that was already kind of in the NV RAM and was acknowledged will come down into that exact same point in time. And so this gives us quick and consistent recoveries. And so this does not interfere with any kind of SQL. Sorry, 1 second.
Yeah, Rob, along that lines too, is so these, they're crash consistent, they're also zeros done, meaning there is no pause of production IOs. If you ever go through SQL Server, sometimes with other storage vendors doing this kind of process, you'll see in the error log, basically IO was paused for this many kind of seconds or frozen kind of stuff. You'll never see that with this process. So you can do this all day long and never find one of those because we're not going to pause any IO to SQL Server.
And we're not going to mess with your log shipping or any other things that might leverage an archive bit or anything like that.
In that regard, are you using the native backup or are you doing EBS volume backup?
Neither. We're using a custom proprietary Tintri technology.
Okay, fair enough.
So we're doing it at the file system level. And what's great about these snapshots, I'm going to pause for a second. So thank you. That was Shawn Meyers who joined us. He wasn't able to make it a bit earlier, but he was able to join us now. Shawn is a longtime DBA, joined Tintri about a year ago to help us as a subject matter expert in SQL Server, and is the role of field CTO. Works with a lot of customers, and has like I said, a really rich background in not only SQL Server but also infrastructure. So Shawn's a super welcome addition to Tintri and has been helping with a lot of the testing and stuff that we've been doing in order to get this to GA. So thanks for joining us, Shawn.
Sure, yeah, and I live in Florida, and so I'm very involved in the SQL user groups in Florida, not the California one. So if you're talking to anybody from Tampa, Orlando, Jacksonville, that kind of stuff, and I'm involved in those groups a lot more than I am on the West Coast ones.
And yeah, so this was just the snapshot policy was showing here that we can create these snapshots. These are great just in case things. Maybe you want to use your native SQL backups, feel free to. But these are an awesome safeguard and they allow so much more. So, and what I want to demonstrate is the more that they offer. So I'm just going to set an hourly, a daily, and a weekly on here. And I want to replicate it off to another VM store. My environment, I'll put it onto 850, I think, is up and good. And I'm just going to save that. And so with this protection policy on here, as data changes and stuff, we're going to get our snapshots showing up here. So because I just added this and it's 0 in size and really is a null, nothing database, I'm going to go back to my, my database list here and pick on something else that might be doing something right now. Let's pick on this prod AW DW. It keeps showing up. And this one does not have a snapshot policy. So no snapshots to work with on it. If I need to, I can go and look at a master list of snaps. But what I was thinking here was I'll just click through and find something with some snaps. So this one's got a couple on it, a little older. This one's only got a couple as well. So we need to get some new snap policies going on some of these. And yeah, so snapshots, let's say that AdventureWorks, this one, for example, which happens to live on this TSIS AG node 2 and is doing, a little bit of 400 megs of throughput right now at the moment. And if we wanted to restore this and not interfere with anything, we could easily go to the snapshot and we can take it and we can say clone that to ADV recovery demo. And instead of putting it on the same server, I actually want to put it somewhere else. So I don't want to load my production server with it. I want to I want to make sure that I can put it on a server that's not going to interfere with it. So I'm going to pick this one, the Lenovo SQL 1, and I'm going to choose an SMB share to put it on. And I'm going to put it in this 850 on the database share. I'm going to hit clone. And I'm going to go over to my Lenovo SQL 1, and I'm going to look at my databases here. And I'm going to refresh. And I'm going to see my ADV show up in here. And if it doesn't show up in here, it's because I may have picked on a share or something this server may not have access to. And the clone failed on it. Unable to open new database. Yeah, so maybe I should pick on a share that server has access to. We'll do that one more time. And actually, before I do this, why don't I check the shares themselves instead of just guessing? So SMB shares on the T850, really simple to create. Add a share. We put a share name in, such as Rob's share. And on here, I'm going to assign this SQL Servers group, full control. And I'm going to look at Rob's share. And I have inherited this built-in super admins that I can get rid of if I want. I have the SQL servers on here. And I should be good to go to see this particular one. So let me just jump back. And the one we were working with was VentureWorks, I believe. On the 850, yes. Clone. Demo 2. And again, I wanted to put it on this particular SQL server. And we're going to add it into Rob's share that I just created. And we hit clone on that. And at this point, it should show up. Now, if it doesn't, then there may be more to this underlying snap that I don't know about because I'm just picking random things. And this is a lab environment where things get tested. So, so this one failed. Great.
Hey, Rob, pick any database on pass prod and then clone it to wherever you want to, and you do pass dev, and it works.
Pass
That's
prod,
what I use the most. Yeah.
Okay.
Your physical box,
thing,
I rebuilt everything. I may not have done the permissions properly on all those.
The other thing that gets in the way too, which may or may not have been a cause behind this, is SQL Server versions. If the database is on a SQL Server that is, say, Server 2019, and I was trying to clone on to a 2016 server, that can give us some issues. And that's the same thing as if you were to take those MDFs, LDFs, and try and add them in there. So which one were you saying, Shawn?
Pass dev, just clone to pass prod.
Okay. These on the 880. Okay.
Yep.
So I'll clone the, is there any snaps yeah, so
yeah.
should I use one of these snaps then as a recovery?
They work like a champ, so sure.
Okay. And this was ADV cover take 3, because this is live. Should I put it on pass prod because we know that server's good, or do we just roll the dice and see if there's
move it back past dev? Go to pass dev.
Pass
so it's
dev?
a different server. Yep. And
Okay.
use the dev DB share because I only allow the pass dev to see. The dev server is going to see the dev share.
Okay.
So don't. Yep. And then boom.
And it's done. And that was called pass dev, you said?
Mm-hmm. So go back to your management studio and just click the pass dev.
I don't know if I have permissions.
You should.
So.
I give you permissions.
All right. So there's my
recover
take 3. Okay. And if we go into HQTM T850 was the other one that I was monkeying around with into Rob's share. We can see that the clone was successful and it didn't add to inventory for some reason that's unknown. And the other one that I had done was into, I think it was dev DB share. Nope, this one doesn't have access to it. So databases, and yeah, it was sitting right here. So these are the files. Now this database was, let's see, in size, it was files. Sorry. So this one's 2 terabytes. It looks like it was provisioned at 2 terabytes, or it is 2 terabytes, right?
That's gigabytes, Rob.
Bytes. Okay, 2,000 megabytes.
Gig, yeah, it's gig, not meg, or get not tera.
2,000. Oh yeah, no, this is nothing. This is too small.
It's a tiny little one.
Okay. Yeah,
I
guess anybody can clone it that fast.
Yeah, but the Ventureworks DW is the big one. It's a 300 gig database. So sorry, I thought you used that database.
So this one, we want a copy of it. So
yep.
Overview, it's using 67 gigs on storage, but logically it can be larger than that. If we were to look at where it is, it's on that pass prod server. So we go to pass prod, this is pass dev. We'll connect to pass prod. And if anybody has questions along the way, feel free to just jump in, throw them out there. I tend to jump around a bit. And here's our AdventureWorks DW. And pass prod's 2016. Is that accurate? SQL? It says DW 2017, so it might actually be 2017, which
yeah, 2017
would probably explain why my 2016 server couldn't load it.
Exactly.
So we can see that it's 330 gigs. Am I doing the math right this time?
Correct.
So the time it takes to clone it is the same. It doesn't matter if it's tens of terabytes or a couple megabytes. So to clone it, if I didn't have a historical snap, that's no problem. I'm just going to hit clone and ADV, Rob's copy. And I'm going to create a new 0 stun snap right now. I'm going to put it on the same server, pass prod. Or should I put it on pass dev? I'll put it pass prod and I'll put it into dev DB. Was that where it was allowed to see?
Yep.
Okay. Clone. And when we go back to it, we refresh, it's done. And there it is. Now,
that is quick.
Yep. So what's nice here is that now we have something that's logically 330 gigs in size. It didn't take any time at all to create the copy of it. The no stun to the primary database, 0 size used, and all we're going to use in space is just the deltas of change. And even those deltas will be compressed and deduped, so it'll take even less space on storage.
How does it manage permissions? So I'm not talking about the database permissions, but let's say you had a specific login connect. Is it smart enough to go and create those?
No. So basically, so obviously, the users that are, so there's logins and there's users. The logins are, of course, at the server level, and the users are at the database level. So all the database users are there, so the logins are not there. So you'd have to bring those over manually.
Got it.
Or have them at times. Or, of course, SP help rev login, which is that start procedure from Microsoft that you can download, will help migrate them so you have the UUIDs or the SIDs or the UUIDs match properly, so you bring it over.
Got it. What about, let's say, cloning from Windows and restoring to Linux? Is that an option?
It's not an option today. So today we're only supporting SQL Server on Windows over SMB3.
Okay, fair enough.
Now I'd love to get SQL Server on Linux over our NFS protocol, because it too is a custom protocol we built from the ground up that cuts out all the crappy noisiness associated with NFS that people usually think of, right? When they think NFS, they think slow. And in this use case, especially for virtual machines, but for databases too, there's not all that attribute chatter that would normally be there. So it's all payload, all data, and our networking is 10 or 40 gig networking.
Got it. Can you take us? Can you clone a database that is part of always-on availability group?
Yes, you can, and you can clone the primary or the secondary, and it will work the same way.
Would that hurt any performance of the primary?
No, regardless, because we're doing it at the storage layer. It's beyond SQL Server's visibility to do it.
So this is what Rob was saying about freezing I/O. In case of you using Tintri, you don't see I/O being
correct. So we're doing it at the storage layer. So the cool thing about the if I clone, the fun part is if I actually clone the secondary, which shows on in SQL Server as recovering, it shows as synchronizing kind of stuff. I can clone that. And of course, I can clone. So if I have when I clone the secondary, it comes online as not part of an AG. It's all by itself. It's just a standalone database. The bad news, of course, is you can also clone if you happen to have a asynchronous replication. You can clone from the asynchronous replication version. The problem is you don't know where it's at. It's just like you would do a failover.
How out of sync it is.
Right. You don't know how far out of sync it is because it's
fair enough.
But you can clone it though. So that way, if you happen to have a DR site, so a customer use case, for example, you have an AG, you have two primary, you have two nodes at primary site and one node at the DR site. Your dev people happen to use the server at the DR site. I have replication going from the AG perspective. I can now snapshot and clone at the DR site. So my developers now have a fresh copy in the test dev server. It's just out of sync from prod, but it's a test dev refresh. I don't care if it's out of sync by 2 minutes or 10 seconds or whatever it is.
Okay, you can basically clone any database. What about, let's say, MSDB?
You can clone it. Well, first but you wouldn't want to because you'd have to overwrite. You'd have to drop. So when we do cloning processes, obviously, I can clone a database. The problem is, we have to do a detach and reattach process. So you have to detach the existing database, and of course, you can't just detach the MSDB. I've never tried actually.
If it was an interest, you could clone the virtual machine, right?
Yeah.
Okay.
So if you wanted an entire working copy of that SQL as is, and it's on a virtual machine, we can clone that out. And the clones on VMs are the same speed as these database clones.
And you definitely can snapshot it. And so that way, if your MSDB got corrupt somehow, you can recover from the snapshot in seconds. So say, before I came to Tintri, I used to work at House of Brick as a consultant. And so I did a lot of engage with a lot of customers. I had a customer, they used a lot of DB mail processes. And so their MSDB was, in the, like 80 and 90 gigabyte size, which is just painful to say. But so say if they had a corruption issue in that, with the clone or the snapshot, I could recover, obviously SQL Server had to be stopped to do this, but I could recover MSDB to that latest snapshot in a few seconds instead of trying to restore it, from backup.
Got it.
That's my favorite use case of this thing is the whole quick recovery. So say developer goes in, does an update without a where clause. on a 2 terabyte database, you have a snapshot that's 5 minutes old, I can either A, replace the existing from that snapshot, or B, bring a new copy up to the same SQL server that's 5 minutes old, and then allow you to go do a join query to join off the data that got updated that shouldn't have been. And so you'll spend more time in your meeting discussing how you want to solve it than you will actually using the technology to solve it.
Got it. Fair enough. Thank you.
Sure.
So the I guess what we're really pitching and proposing here is all the ease of use of storing your databases without having to know the backend storage into easy shares here, right? And lumping them all together, and then the auto discovery to find those databases, and then do the tuning for them automatically and allow us to apply policies to them. Once they're recognizable objects in the storage, we can do even more. Everything I demonstrated was from the UI, and but we also have a PowerShell toolkit that we can use to do the clone. So you can script it. So you can create some great workflows to script it. And what we've done is at Tintri, we really pride ourselves on simplicity. And so what we've done is we've abstracted out all the things so that when you want to clone a database, you don't have to go to a spreadsheet, figure out the LUN number and all these crazy things of what to clone and where. It's just the name of the database and where do you want to clone it to, and nice friendly names of the objects that you're working with. So on the administration side of it, one of the things that's required is adding a SQL Server. So in order for those to show up, we need to put a SQL Server in here. I don't think I have any in our lab that aren't registered already. So I could either remove one or add a new one. But if we look at our list of all of them here, it's just a simple add. And then I'm going here and I'm saying, you had a tease standalone. Oh, you have a AG node 1, right? That we've not added.
Yeah, no, that's on the TGC DB.
Okay. So don't do it.
1803 though is 1803 is registered. So never mind. So yeah, okay. They're all here except for my log shipping ones, which I don't know the names of them because I'm going to delete those pretty soon.
Oh, LS test or whatever. But okay, so whichever server you have, your SQL Server name, IP, FQDN, your username that you're going to connect with, which today is just Tintri SQL, SQL authentication. The password that you want to connect with, and then advanced is if you wanted to use a custom port or a custom instance. So if you had dozens of instances, all of them are going to show up as different SQL servers. And then when we're doing our cloning and we choose what our destination will be, we can pick any one of those discretely and say, hey, I want to put it on that server, that instance, and do our clones appropriately. And I just realized that when I was cloning, I picked that database DW 2017. It should have been a clue that it was a 2017 database and wouldn't load into my old 2016 server I was using. So that was on me.
And my guess is the interface is still not smart enough to tell that it's not compatible.
The next rev, yes. So that is been developed.
Don't go promising anything, Rob. So we've requested it. Engineering is not officially blessed they're going to do that because we also had to have the discussion on, do you actually want to check database version or just want to check SQL Server version? Because in 2014, they had one CU that upgraded database version. So if I was on CU 12, I could not actually restore back to a CU 11 because they changed version. I'm like, that's such an edge case. Do I want to program around all the difficulties or just assume everyone, if you patch your SQL servers, you patched all of them? And so, yeah, we're not, we're going to have it eventually. I can't guarantee next release, but will be soon.
Okay.
Rob likes to overpromise sometimes of, hey, we requested it, they're going to do it. We know they're going to do it. And then we have those fun discussions later on.
Yeah, well, you can always safely say tomorrow because tomorrow is every day. So.
Exactly.
Yeah, I said tomorrow. I was not here yet. So, but no, actually, this is something that's been in the works for a long time, over 4 years, and it took it's gone through a lot of hardening and a lot of testing to get to the GA that it's at now. A lot of refinement before it even saw the light of day, which isn't normal. Typically, things come out sooner and then the refinements come. But this one actually had a lot of polishing due to certain circumstances. And,
so
yeah.
adding a question about the, so you can basically drop an MDF file into that Tintri drive, and it's smart enough to see if the file, let's say, because so there's a typical problem between transactional database and data warehouse. Data warehouse usually gets more reads. Operational gets basically more insert deletes and updates. So this is usually the competition between read and writes. So what you're saying is whatever database MDF file you drop there, Tintri is going to be smart enough to optimize it for more reads or more
how
writes.
it's using the storage. So for both.
Got
so
it.
what we're doing is we've taken the IO and then we've associated a cost to it. And the cost is not the same for all block sizes, and it's not the same for reads versus writes. So because we know the IO, the exact IO to the files that make up our database, we know exactly how it's been using it, and then we can sort of assign a cost to it. We call them reservations. And so our systems have reservations on them at the VM store level. So at our appliance here, like this one, for example, has 1,200 VMs and databases sitting on it right now. And if I look at the dashboard for it, I've got a couple gauges. One is really simple around space. Do I have free space, yes or no? And the other gauge is going to be around those performance reserves. So right now we've used about 51%. We've got 49% free. And if we wanted to drill in and figure out that percentage and who is actually using it, I can click at any point in time and see those contributors. So I can see that at that point in time, NTT LS test was using 0.5% of the bots. Now, if I were to look historically, I might see some ebbs and flows here. And in this case, NTT LS test was using 67%. And I can go to my other arrays or globally look at an accumulation across the board of everything and see on those metrics, you know, kind of who the hogs are, who's taking up the most. So reserves, which is what I was looking at. Whoops, sorry, my scroll got stuck here. And the biggest hitter in this environment at this time is this Win16 SMB host, that 4 terabyte one that's handling the backups for these SQL servers. And it's consuming 3% of the box that it's on. And as this adjusts, it makes sure that that 3% doesn't get cut into by other things. So just because it lets up a bit, that will give others, but it's use it or lose it. So in all these graphs, these weren't good examples because they kind of didn't fluctuate enough. I guess it's more of a normalized average of everything. But what happens is more of a use it or lose it. And if something isn't a big heavy hitter anymore, then it will drop down and not have those reserves. And then when it hits again and needs it, those will get ramped back up based on the real demand. And it'll do that without impacting the other stuff. So by far the simplest kind of storage administration ever. It's a, do you know how to operate an SMB share? And then if things don't go well, we've got all those metrics to show that it's an infrastructure problem, or you better work on your queries.
You know, and that's the wrong way, but for me, it's so simple. Even DBAs can manage the storage. It's not insulting DBAs kind of stuff. It's just saying it's that simple, because if I put you in front of any other storage array out there, they're so convoluted and so many bizarre instruction sets on what they do for things, you'd have no idea what it's doing. Here, the UI is simple enough. Just clicking around, you can figure out what you're trying to do. You know, I actually had one of the members of, I was showing this to the one of the members of the Tiger team, you know, from SQL Server at Microsoft, and you know, he could figure out how to do replication and data protection policies for his databases by just giving him the UI. You know, he's not a storage guy. He's a member of the cat team, and he knows more about SQL Server than I do. But you know, the cat team, the Tiger team, you know, working for Bob Ward. But yeah, he could figure out all this stuff just by clicking around himself. So that's one of my things about this. I don't need the experts to do things for me anymore.
And this is only, so there is only a web interface, right? There is no other than that extended session. There is no plugins into SSMS, for instance.
Not yet. That we
Got it.
want to bring an SSMS plugin. We don't have a timeline for one yet. And the other mode to interact with it are directly through REST API calls. PowerShell Toolkit was just released this week, including the new support for Tintri database support. So
Got it.
Get dash Tintri command status new. And so this latest release of version 4 adds these commands to the whole list. So this is add a Tintri DB server. So that was the operation that I added a SQL server that will be queried and auto-discover the databases on it. And if they exist in the SMB shares on the that are managed by this global center, then those databases will become real boys. They'll grow up to be a managed object that our storage knows about, looks out for, and protects. If we don't do that, they all live in the stray file queue, and it's a big free-for-all, equivalent to all other storage that operate that way.
Got it.
We've got Tintri, get Tintri-DB, so connect Tintri server to HQTM. Oops.
So this is a commandlet that you can download from Tintri, right?
Yeah, it's our Tintri automation toolkit.
Got it.
Yeah, so yeah, it's basically a PowerShell module, so you can just load it into your normal PowerShell.
It's not part of DBA tools.
No.
Okay.
So I just
Tintri code
and get Tintri DB and just simple list. So those are the databases on here. And with them in here, I can specify dash host name, for example, is lenovo-sql1.ttucs.tm.tintri.com. Just rolls right off the tongue. And this is all of the databases that live on there. And so if we were doing that previous command, that is to get the databases so that we can pipe them into other operations if we want, such as a new Tintri snapshot or a new DB clone. And we can create these file shares, these SMB shares through here if we want. We can grant access to the file share through here. We can clean things up and delete them through here. So really flexible. Let's say that you had a workflow that you cloned a SQL VM for somebody. So there's 10 seconds for the VM clone. The thing powers up, your script runs through. Then you want to go take that name, add it as a SQL server to monitor, put it in there so you get all the goodness here, and then start cloning databases to it. All of this can happen very quickly.
For me, yeah, and the thing for me is I always take this, I actually go right to, I've got internet problems, looks like, according to Zoom. Hopefully you can still hear me, but things I tend to do with this was, I write my script. Okay, I write my script, and then I go ahead and plug it in, and actually I can run it, call it from SQL Server agent as a job that does a PowerShell script. So I can now do it, have a workflow inside of SQL Server that does all the work, and it just drops out, does some storage tasks in my process, i.e. clone a database, drop a database, whatever process, and then I go back into, back into SQL Server command. So I can even call it from inside of a stored procedure if I really want to get tricky, but I tend to do from a SQL agent job, and so I do a lot of wraparounds that way. I'm weird when I do so much stuff inside of PowerShell through SQL Server. It's so easy to do, and I don't like using PowerShell by itself. I like to have a scheduling engine around it.
And just while Shawn was talking, in the background before the session tonight, I had fired up 9 HammerDB clients to start picking on some of the different databases that are in here. So this one was doing like 145 transactions per minute. This one was it's probably just finishing up pretty soon. And so these ones were actual databases that would show up, because I didn't want to have just a list of static databases with nothing sitting there. So if we wanted to see, again, quickly, is anything running right now on any of the databases, I can go to my list of databases and look at throughput, idle low, and these are databases that are there. And if I wanted to look broader in the whole environment of all the VMs and databases, so there's almost 1,700 various managed objects in here, who's doing what right now? SMB host is, and that means it's probably doing a backup job. And it is probably the reason that this one is getting network latency as well with it. But yeah, so really you want to find who's taking the most space. Really quick, okay, high to low, this 4 terabyte VM happens to be the largest. This is after compression and stuff. Some of these might be larger provisioned, and this one's way larger and takes a lot less space on disk. So there's one last thing that I want to show that I should have got to a little sooner. And that is, I mentioned earlier in the call that we have Tintri Analytics that will show you that 3-year trending history. So carrying on with our simplicity, this is a snapshot of this is the auto support data that comes out of these VM stores that our support uses to, so if you call in with a problem, they already know what's going on. If there were issues, we proactively sent replacement parts. The storage itself is enterprise grade, HA, dual controllers, totally redundant, fully HA and everything. And then this is a layout of my whole environment. So in this case, I have 11 VM stores, and I can look at the trend of this going back for the last 3 years. And at any point in time, if I'm interested in something, such as this performance spike that got busier in June, I can click into this. And because of that granularity of the level of management that we do, this is, let's look at it, throughput. So of throughput on that day, the peak ones, this is what we call a peak busy hour. It's a way that we can sort of represent the performance of a VM or a database at a whole day granularity. And so a standard average definitely wouldn't work. So we've got this 1.1 gigabytes a second is the busy one that day by a system by the name of RG Tingle 01. And I can look at the next busiest, and I can see through my environment by counts of all those VMs and databases, who's doing what. So in this case, I can see there's 6 VMs, 0 databases. And in some cases, I'll find that there's, databases are the busiest. So if I look in these ones, this one happens to be databases, and WDemo was busiest on that day. And we can look at any of these trending over time. So I can refine this even further. Instead of just all the objects, I can say, you know what, just give me my databases or any of these groups that I've created. So I've created a group for AdventureWorks, for example. Oops, I'm in the wrong list. These are all the ones that are being shown. This is my refinement of groups. So I can say all DBs. And here I can see the distribution of databases, the throughput on them for that day. And then I can go and trend this over time to see, and this is going to be kind of boring because it's not going to go back very far. And throughput, for example, and we're only starting in July, which is when we released this database feature GA. And so that's when we started in analytics counting, then going forward. And so that blue line are the number of databases. And we peaked out at around 120 in the environment. We dropped down to 58, came back up, and we're sitting at 118 in the environment. And this is the performance. Now this performance is an aggregate of them, but I can also look at average for each one, or sorry, not each one, the average for the group that I chose. And in this case, it was all DBs, but I could get more refined with like AdventureWorks. And AdventureWorks, I can see that that is not the AdventureWorks, or I don't know what that definition is, but it's certainly not, the count is way too high to be AdventureWorks. Let's see. I'll add a new one just so that I can be sure that I know the rule set on it. So I think what was the one that I created? It was SQL Malibu, have demo, for example. So I can say anything that's got demo in the name of it and happens to be a database. And there's 10 matching objects out of the tens of thousands that have been in this environment historically. And now that I've got that application here, which was it? Oh, what did I call it? Yeah, this one, demo. Now I can go look at the trends for this. So that IO performance trend. So we can see that while there's 10 today, there used to be 8 of them. And so what's really cool is all of this is coming as a byproduct of where you chose to store your database. So not only did you get all the operational benefits, but now you have this ability to trend it historically. This will give you advice and heads up if there's any serious concerns in the environment. And we've got a planner to model what the impact of new workloads, databases, for example, are going forward. So let's say you've got a database that is for an antivirus product that maybe doesn't run great. What happens if you had to have another deployment for another company you were acquiring? You could use this to model, what if I added this new object on my future date, and the object I want to add is not that average VM, but it is, say, demo in the name, and it's the average of all of those. And I want to put in 5 of those. We can see that in this case, it'll have very little impact on to this, all of the VM stores. If I got rid of most and just kept my smallest, slowest one, pick on T820, I guess, then maybe it should make more of a dent on that one to add those 5. So we've got this trending and modeling here. So I've taken a lot of your time. I appreciate the questions that you had, Steve. Anyone else has questions? I'll pause.
Well, so far I see one comment. Thank you, very informative. But please feel to unmute myself and ask.
And if you're shy and don't want to ask right now, that's also okay. You can reach out to Shawn and myself, Shawn Meyers and Rob Girard. Really high tech here, right?
You should do it in a query, Rob.
You can. I'm
Well,
yeah,
don't hit the F5 button. So
exactly. I mean, you know you're a database geek when you actually use, write a query to do a calculation.
that's actually what I did.
Yeah, I do a lot too.
Calculator, Excel, or Manager Studio.
Mm-hmm.
Does Tintri Analytics doing any predictions? Let's say like space or IAPS or.
Awesome. Yes. So the infrastructure here has actually, there's a learning model on here going back to 3 years to trend. This is all 11 VM stores moving out the next 18 months. And if we predict that it is going to give you problems, we're going to throw you an alert like this one. So if I click on this one, this says that HQTM T850 is predicted to exceed 95% storage. Working set. That's that cyan color. So the working set on a hybrid is like the active flash blocks. So it's the part that needs the flash. So the working sets vary for everything, and you can't tell how big a working set is based on any outside metrics. You couldn't look at IOPS or throughput and size of it and say, oh, that is a 50 gig working set. The working set are all of those hot flash blocks that are used over the course of a period of time. And so what we've seen is that this one was increasing, and now it's starting to come down. So our prediction is going to every day recalculate. And so this won't be true today. This will come down. If it comes up too quick, these alerts will hit. If I go from active alerts to all activities, I can see performance on a T5040 was an issue back in August 4th. It first triggered. I acknowledged it, and it was kind of teetering on the line. And then performance now is good. So performance had ramped up before. We thought that it was going to keep going. It's kind of come back down, and we haven't come all the way back down yet. But it was just sort of in the warning zone. So this is intended to keep you, so you know what's going to go on into the future. And these curves were brought into that planner that I did. It's just that when I was in the planner, I was looking at the whole environment. And if I just looked at D820, for example, it's going to have some growth going out on it. And that one that I was looking at, I think it was 5040. And it'll have its own kind of projections going out here.
Got it. How much of this functionality is available in SentryOne?
So we have a plugin for SentryOne, and so the plugin there, so the after the fact metrics of showing you that latency, that SentryOne plugin will talk to a Tintri VM store, and when a database has latency that it calls storage, it'll actually go through REST API and subdivide that down and break it out into that host network storage that I was showing, that breakdown of latency. So they have an integration there. So I like to think of the Tintri stuff as the first pass macro stuff, the high level, is the infrastructure healthy? And then I would think of SentryOne and SQL Sentry as the microscope. So now that we've identified someone's not very healthy, let's drill in and figure out why.
Got it. Okay.
And so SentryOne will give you, so as much as I show the metrics, I really, really can't stress and reinforce enough that the value is in what you don't need to do operationally. And these metrics are a byproduct of making the right abstraction to measure at the object level that you care about as an administrator, whether that's databases or virtual machines or the vDisks inside of them.
Got it.
Any other questions, comments? I realize that this is a vendor pitch, so I hope you knew that was what you were signing up for. You know, we just want to show this, and I chose this interactive format. You know, did I have errors come up? Yes. I had 2 clones that failed. It was my fault. It exposed that our error message handling isn't as good as it could be. But I think that, you know, we're trying to be that honest vendor out there that puts it forward, shows it real time, live, shows it exactly for what it is. I'm using real data from an actual lab that is, you know, we do all kinds of crazy stuff in there. Doesn't always show well. Sometimes it breaks and looks kind of ugly, but it doesn't crash kind of break. It is, you know, painful performance and stuff, but it's doing what it's supposed to do, and it isolates stuff. And if it ever doesn't, we've got a really clear path to exactly who the culprits were and what had gone wrong.
Got it.
So with a pretty quiet audience, I want to thank you again, Steve, for having us on tonight. And I want to thank everyone for their time. And again,
there was another comment from Paul saying, thanks, interesting information.
Okay. Thanks, Paul.
Any questions? This is last attempt. Well, thank you for joining Los Angeles Data Platform. Thank you, Rob and Shawn, for presenting next generation infrastructure session.
Thanks, Steve, and we'll catch you next time.
Okay, thank you.
Thanks.
Bye.
Bye.